predictions for this year's space economy, and last year's record-breaking climate data. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. There was a lot of success in the space industry in 2024, but what will 2025 look like? The firm Space Capital released its data on last year's space economy, as well as predictions for this year, including things like how AI will be vital in upcoming space missions and how a new presidential administration will affect aerospace companies. We'll speak with Space Capital's Chad Anderson about these findings and predictions for space exploration in 2025. Then, 2024 was the hottest year recorded since the mid-1800s. That's according to NASA and NOAA's latest climate data findings. We'll speak with NASA's Gavin Schmidt about how greenhouse gases are playing a key role in the planet's hotter climate and what 2025's weather could look like. That's ahead on Are We There Yet? This year, SpaceX continues to test its massive Starship rocket, and Blue Origin is set to launch its first maiden mission of New Glenn, that company's orbital vehicle. These two missions and several other planned launches could potentially change the space industry completely and lay the groundwork to send humans and critical hardware to places like the Moon and Mars. But that's not all to look forward to in 2025. Space Capital, a seed venture capital firm, released its predictions for the year, saying that 2025 could very well be one of the most transformative years for space exploration and the economy. Here to talk more about the Space IQ release and how things like AI, commercial space companies, and missions to the Moon and Mars are changing the industry is Chad Anderson, founder and managing partner at Space Capital. And a note for our conversation, Anderson is an investor in the company SpaceX. Chad, welcome back to the show.
Yeah, great to be here. Thanks.
Hey, Chad, every time we chat, it seems to be getting more and more exciting and busier in the space world. We're going to talk about what you foresee coming in 2025. But before we do that, can you give the year 2024 a grade in terms of what happened in the space economy?
It was a really difficult year in the financial and capital markets. We're coming off of the run-up in 2021 and the zero interest rate period. Capital was cheap. Things got tough over the last 2-3 years. That has certainly been felt across technology companies and companies across the space economy. But innovation does not recognize market cycles. There has continued to be an incredible amount of innovation in the space economy, and we've seen space companies doing amazing things. We had another record year of launch activity and launching a lot of really important infrastructure satellites that are providing resilient positioning and timing, satellites that are providing connectivity around the globe, Starlink satellites being chief among them, in disaster areas, conflict areas, and rural parts of the globe, unconnected parts of the globe, which are vast, and a lot of satellites with really interesting sensors enabling us to do things like track methane emissions globally for the very first time, I might add, and new initiatives announced and underway to track wildfires and provide actionable intelligence on them so we can actually find them early and take action and do something.
Chad, you mentioned the wildfires, and I do think it's worth pointing out that a lot of the information that we are getting about what is happening in California is coming from commercial imaging satellites, and then also the connectivity of people that have lost internet and broadband, including first responders, is coming from Starlink. I mean, that's going to show you something about just the practicality of the space economy, right?
Yeah, I mean, as the world becomes more dynamic and uncertain, people want more information, not less. And like you said, I mean, I think a lot of people have this misconception that, space is this luxury item. It's for billionaires to take joy rides and jaunts up into space and have fun. That couldn't be further from the truth. I mean, a lot of people focus on that, and that's certainly happening. But space technologies are providing essential information and insights. They power the global economy today, and they enable essential services like you just mentioned.
So you mentioned 2024, a lot of this infrastructure was put in place to help in 2025, which your organization writes could prove to be one of the most transformative years on record for the space economy. What are we looking forward to?
Yeah, I mean, there's a lot of reasons for that. One of which, we've got an administration coming in that is very bullish on space. We expect to see greater focus on promoting the space economy and on commercial space integration into government programs. I think SpaceX is probably going to be obviously the biggest beneficiary here. And that's not just because Elon is first buddy. but also because SpaceX has the market-leading solution. So enterprises and governments around the world are looking for enhanced capability, investing in space infrastructure to enable greater capability. SpaceX is often the best solution out there on the market. And so they're going to benefit greatly from a lot of these contracts. But other companies are going to benefit as well, most notably probably from a light touch regulatory regime. Commerce is overseeing novel space activities. And so, we're seeing some of those capabilities come online, down mass, bringing things back from orbit safely to the surface of the planet and recovering them. If you look at Starship is coming online, they're going to accelerate growth, massive next generation vehicle is going to launch a whole lot more satellites. If you look at the chart of the number of satellites being launched into space over time, in 2024, it is a straight line up. We are launching a lot of satellites. Starship is going to enable us to launch many more satellites with many more sensors and capabilities. It's been a nice thing to have, right? Space traffic management, coordination of activity, coordination of satellites in orbit. That's been a nice to have up until very recently. Now that is a must have. This is essential. We need better coordination between companies and between countries to make sure that people can operate these satellites safely and we can continue to experience this growth and have this great capability without ruining these orbits for ourselves and future generations.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Chad Anderson, the founder and managing partner at Space Capital, about upcoming missions and the impact on the space economy. And Chad, we should mention you are an investor in SpaceX, but I want to go back to something you mentioned about space traffic there, how it is so important for these companies there. But you also mentioned a light touch regulatory environment here. Are there any concerns that there could be challenges with coordinating all of what is happening in low Earth orbit? And if there are any issues that could be detrimental to this growing space economy?
Yeah, I mean, we actually, there is a risk. We view it as a big opportunity, and we've been deploying capital into space traffic management and space domain awareness solutions for a number of years now. Space is big. So as a starting point, there's a lot of space up there. So we can certainly launch many more satellites and operate them safely and effectively and efficiently. We just need to be smart about it. So I like to think about it in terms of, airlines, when they fly east and west, commercial airliners, they fly with these massive buffers between them. And they do so because there's not great connectivity out over the oceans. If you get smarter, if you get greater connectivity, if you know where things are around you, you have better situational awareness, then you can fly closer together. That's what's going on in space, right? We had satellites that were up there that were relatively not as sophisticated or advanced. They didn't know where things were around them. That has changed. Leo Labs, for example, another portfolio company of ours, have built a network of ground-based radars that can track objects in orbit down to a couple of centimeters. They have, 7+ of these radars around the globe, so they get real-time data. So now we have a really good handle on where things are. That was the first step. The next step is, okay, so now how do we coordinate traffic between the different companies and countries? And we've invested in a company called Kahan Space that is building a solution for that aspect of it. And so space is big. Better technology is going to enable us to operate many more satellites using the space that we've got.
Chad, of these 10 kind of predictions for the space capital markets in 2025, one stands out to me: Mars or bust. Mars to me has always been a horizon goal, kind of what's over the next hill kind of thing. Is this really a legitimate driver of the space economy, getting people to Mars?
Well, it's the very publicly long-held goal of SpaceX. Their ultimate goal and their ultimate vision is to travel to Mars, to colonize Mars, to shuttle humans there, and to establish a permanent presence there. So, in different NASA administrations, it's waxed and waned. It's gone from, let's go to the moon, then let's go straight to Mars, and let's go to the moon as a stepping stone to Mars. And SpaceX would much rather go the direct route. And you've seen that in the companies, in Elon Musk's tweets and things, talking about scrapping. There's no point just going to the moon. We've been there already. Let's go straight to Mars. We have the capability. And they think that they're developing that capability with Starship. And so there's a lot of optimism and confidence on the side of SpaceX. And at the same time, you got an administration that's coming in and, wanting to put another notch on their belt and do something that hasn't been done before. You've heard Trump talk about this before, that, we've been to the moon. So if they go back on his watch, then that's not really, a victory that he can claim. If we go to Mars on his watch, then he can. And at the same time, you've got the NASA Artemis program is, a lot of the elements of that program are way over budget, way behind schedule. So there's definitely going to be a re-architecting and a rethinking of how to get there. And I think likely if Starship continues this fast track development program and they start to demonstrate these capabilities and the vehicle becomes operational this year, which we think it will, then I think a lot of more people, more government dollars are going to throw their weight in a more streamlined architecture, leveraging SpaceX and Starship.
And finally, Chad, what role do you see AI playing in the space industry in 2025?
Well, it's huge. And it's actually, over the last couple of years, has really touched every aspect of it, from, spacecraft operations to managing networks, ground station accessibility, you name it. But the biggest area of opportunity is probably in spatial intelligence. So that is, geospatial intelligence is these Earth imaging, remote sensing satellites, right? Cameras and other sensor types. With SpaceX's Falcon 9, we've seen a proliferation of these satellites in orbit. They're generating an unprecedented amount of new data that is really actually, and you pile this on top of the decades of data that we've been getting from NASA and other satellites, over the decades. There's just way too much data for humans to understand, to parse through, to annotate, and actually derive useful insights from. So we've been sitting on all this really valuable, really interesting data about the surface of our planet, and we just haven't been able to make sense of it until AI. So this is one of the greatest opportunities, we think, for AI, is to set it loose on this really valuable data and to start deriving useful insights and information from it to enable us to address an infinite number of markets. Namely, top of mind is getting our arms around wildfires and being able to do something about it. Everything from getting the data down and actually being able to take action and do something about it in a time frame to make a difference.
Certainly a fascinating year ahead. Chad, thanks so much for joining us.
Thanks for having me.
That was Chad Anderson, founder and managing partner at Space Capital. Still to come, extreme heat in 2024.
And then there's the greenhouse gases, which we still keep on adding to year after year. And so we effectively have our foot on the greenhouse gas, if you like, and that's driving continued warming as well.
A glimpse at last year's climate data. That's ahead on Are We There Yet? And if you got an idea for a future episode of this show, or you want to join us as a guest, reach out to us. We're at arewethereyet@cfpublic.org.
Support for Central Florida Public Media comes from UCF Continuing Education, offering professional development and corporate training services for the modern workforce. UCF Continuing Education provides a range of courses and workshops available in person or online, designed to enhance skills and knowledge in various fields. More at ce.ucf.edu.
You're listening to Are We There Yet? I'm Brendan Byrne. Exoplanets are planets that exist outside our solar system. For years, MIT's Sarah Seeger has been on the front lines of discovery of these planets. We'll catch up with her on the advances in exoplanet detection and what's ahead for the field. That's next week on Are We There Yet? But now, scientists at NASA and NOAA have been tracking Earth's climate for decades. But in recent findings, 2024 was the hottest year on record, going back to the mid-1800s. From heat waves to Mexico and Phoenix to rising ocean temperatures, extreme weather was observed across the planet. But what caused this global temperature increase, and what can we do to mitigate our warming planet? We're here to talk about these findings and climate predictions for this upcoming year is Gavin Schmidt. He's the director of the NASA Goddard Institute for Space Studies. Gavin, welcome back to the show.
Thank you very much.
So, Gavin, NASA and NOAA just released new data about the 2024 climate. What did you find?
It was hot. 2024 was the hottest year on record, going back at least to 1850. What we're doing there is we're just seeing everything warm up, and it's really very clear.
Gavin, how do you go about making a global temperature reading? I assume it's not just sticking a thermometer in the atmosphere and calling it a day. What goes into actually getting the 2024 temperature?
So we use networks of weather stations on land. Those go back to the 17th century in some places. We use networks of ocean temperatures that have been taken by ships and buoys and now floating drones, the ocean's temperature. And then we kind of put that together. You have to deal with some of the non-climatic influences, things like changes in instrumentation or stations moving around. But we can do that pretty well now. And we can take that record back to the mid-19th century. That gives us a pretty good estimate of what's been going on. And things were kind of, noisy for a while. They kind of rose through to the 1940s. They kind of plateaued a bit, cooled even to the 1970s. But then since the 1970s, things have been warming at around 0.4 degrees Fahrenheit every decade. And so we're at the tail end, though it's not going to stop, of a long-term trend in those data. And we can check that. We check it against satellite data that we have for the modern period. We check it against weather forecast data that we have for slightly longer periods, and all of those different systems of assessing that temperature change give us the same answer. The 2024 was in fact the record warmest year that we have seen.
This is just out of genuine curiosity, Gavin. Those early climate records that you're talking, the mid-19th century, where are you getting that from? How do you collect that info?
So we're still digitizing a lot of old paper records. So there's still stuff sitting in archives that hasn't been included, but there hasn't been a lot that now has been digitized. And so we're using all of that. Shipping records, ships take the temperature, every day wherever they were. And we've had international shipping, since the 17th, 18th century. We have got sufficient data. It's not perfect data, but yeah, stitching it all together can sometimes be a little bit of a challenge.
Is there a reason why you can't go any farther back than 1850? Is it an issue with validity or an issue with getting hands on record?
It's mostly an issue with sparsity. We don't really have very much information from the ocean around Antarctica before around 1950. If you go back to the 19th century, there are whole parts of the South Pacific that never get visited, whole parts of the South Atlantic that didn't get visited. And, and there aren't so many well-characterized weather stations on the continents, particularly in the southern hemisphere, as you go back further. So it's not that you can't make estimates. You can make estimates. You can bring in new information like ice cores and tree rings and those kinds of things. But the uncertainties do increase quite strongly. But we're still, the difference between then and now is so strong. Those uncertainties don't really matter for that question.
That's just fascinating. Thanks for appeasing my curiosity there. Let's go back to more recent data. Data you got from 2024. It's the hottest year on record. Do we know what's causing this?
Well, yes, we do. The trends that we've seen since the 19th century are driven almost entirely by our emissions of greenhouse gases, carbon dioxide, methane, nitrous oxide, CFCs. And that's the dominant term in the global warming. Now, exactly what happens on a year-to-year basis, there are more things involved. So we started last year we started 2024 with an El Nino event happening in the tropical Pacific. That's a warm anomaly, and that kind of leads to a warmer year, generally speaking. And so that gave it a little bit of a boost. There are some specific changes associated with cuts in air pollution, both from marine shipping and in China, that have also led to perhaps a little bit of increased warming. And then there's the greenhouse gases, which we still keep on adding to year after year. And so we effectively have our foot on the greenhouse gas, if you like, and that's driving continued warming as well.
When it comes to those greenhouse gas, are institutions like NASA and NOAA, are they able to pinpoint where those gases are coming from? Are you able to drill in and localize it?
You don't need satellites to tell you, though. So the rise in carbon dioxide is because we're burning it. We're burning it as a fossil fuel, burning it for power. We're burning it in vehicles. We're burning it in industrial uses, and methane. We're burning in houses and in factories and in power plants. So we have a very good idea about where the carbon dioxide is coming from, where the methane is coming from, and it's all us.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Gavin Schmidt, the director of the NASA Goddard Institute for Space Studies, about last year's climate data from NASA and NOAA. Aside from monitoring this changing climate, is there anything that NASA and NOAA can do to mitigate this, or is this on governments clamping down on fossil fuel emissions or industry doing that? I mean, what can NASA and NOAA do?
Right. So NASA and NOAA are both science agencies with respect to this. So we're keeping track of what's happening. We're understanding what's happening. We're predicting how things are going to change in the future under various scenarios. But those scenarios, what happens in the future, are very much up to regulatory authorities, governments, individuals, institutions to decide on whether they want this to continue or not. A little bit unclear sometimes.
Some of the noticeable climate findings in this data: Antarctic sea ice ran near record lows, upper ocean heat contents at record highs, but global tropical cyclone activity was near average, which for us here in Florida, we're very thankful for. Is there any insight as to why that kind of remained unmoved?
It's a very interesting topic. So there's a number of things that affect both the number and intensity of tropical cyclones in a year. There's an oscillation that goes between the Atlantic and the Pacific basins that's also associated with El Nino and La Ninas. So if you have an El Nino, you tend to have slightly fewer cyclones in the Atlantic basin. But then there are things like the wind shear, which kind of prevents intense storms from happening. That's a very complicated thing. Our best understanding is that we don't really expect a big shift in the number of tropical cyclones as the globe warms. We do expect an increase in intensity if a storm forms. Some of the rapid intensification that we've been seeing seems to be associated with higher levels of water vapor and temperature in the atmosphere. And then the rainfall amounts associated with any particular storm, those have been going up roughly like 5% per degree Fahrenheit in the global temperatures. So we are seeing some impacts on the climatology of tropical cyclones, but that's more than just the total number in a year.
For our Central Florida listeners, we certainly can feel that intensity and additional rainfall that could be influenced by a changing climate. But I want to talk about those other two findings. Antarctic sea ice ran near record lows. What is the impact that has on us, here closer to the equator?
Right. So the direct impact of Antarctic sea ice changes is not very large. That is, in fact, a long way away. But it is indicative of how we are changing the climate on a global scale. And the things that happen in Antarctica that do affect the coast of the United States are, of course, things that are associated with sea level. So we know that Antarctica has been losing mass. It's been shedding ice into the ocean at about the rate of 150 gigatons per year over the last 20 or so years. It's actually decreased a little bit in the last couple of years, which is good news. But I don't think we expect that to continue. We expect Antarctica to continue to lose mass, and that's adding to the sea level, which is adding to the coastal surges, the sunny day flooding that is occurring all up and down the East Coast.
What about upper ocean heat content? First of all, what is that? And two, what does that indicate?
Oh, yeah, no, that's a great question. So, the greenhouse effect works by trapping heat that's coming up from the surface and making it harder for it to leave the atmosphere. So when we've increased greenhouse gases, we actually have more energy coming in from the sun than is leaving from the system. Well, where does that energy go? It mostly goes into the ocean, because that's where the big heat capacity is. Like it doesn't take very much energy to warm air, but it takes a lot of energy to warm the ocean. And so almost all of the energy that's coming in is going into the ocean. And so tracking the heat in the ocean tells us that we're warming because of this imbalance at the top of the atmosphere. And so we understand kind of why things are happening, and we know that we're not kind of getting a prediction right for the wrong reason. For ocean heat content has a direct effect, right? It's the SSTs, the sea surface temperatures, are the direct fuel for things like tropical cyclones, and they also add to the sea level because the warm water expands. So that's another element there. And then things like coral reefs, they're very sensitive to the upper ocean heat content because it's basically just warmer water. And I know that kind of like last year towards, in the summer, you saw some ridiculously warm temperatures in the coastal bays around Miami. And those are again kind of associated with this big increase in ocean heat content.
And finally, Gavin, I know you just released this data, but in 2023, data you found was the hottest year on record. 2024 is the hottest year on record. Are we on pace to be having the same conversation a year from now?
Thankfully, I don't think so. I know that a piece of good news there.
Yeah, that's nice.
Well, we started last year with an El Nino event. That's the warm phase. We're starting this year with a slight La Nina. So that's a cool phase. And so we expect that to kind of like moderate temperatures a little bit. But having said that, 2025 is still going to be a top 3, top 5 year. And it's not inconceivable that it could be up there again. We made these same predictions for 2023. And I'd be wrong to say that all our predictions have always come true. And in 2023, we didn't predict that it would be the warmest year, and it really surprised us. So you have to take those kind of predictions and perhaps a little bit more with a little bit more salt than you did before. So we don't think that 2025 is going to be another record warm year, but there are a lot of surprises in the greenhouse.
Well, thanks for keeping us updated on the temperature of our planet, Gavin. Gavin Schmidt, thanks so much for joining us.
Thank you very much.
That was Gavin Schmidt, the director of the NASA Goddard Institute for Space Studies. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, YouTube, the NPR app, really wherever you get your podcasts. Stay connected with the show. Follow us on social media. We're on Instagram and Facebook, AWTY Space. And if you got an idea for a future episode of the show, or you want to join us as a guest, reach out. Our email is arewethereyet@cfpublic.org. More space coverage online, visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marian Summerall. Our new intern is Allison Castillo. Welcome. Editorial guidance from Latoya Dennis. Support for Are We There Yet comes from our listeners. I'm Brendan Byrne. Thanks for listening.